In this episode of Circular Dimensions, we'll be taking a closer look at the linear dimensions and their circular mappings to reveal another mysterious property of our universe. It's very simple. The 0th dimension is a point. A line of these points forms the first dimension, the infinite line. A line of these lines forms the second dimension, the infinite plane. A line of these planes forms the third dimension, the infinite cube. A line of these cubes forms the fourth dimension. What would that look like? We're stuck. Rigid linear dimensions have failed us, but they did teach us something very important. Each dimension is a single slice of its higher dimensional neighbor. The plane is the slice of a cube, the line is the slice of a plane, the point is the slice of the line. So what is the cube a slice of? A prior episode showed us finite mappings of infinite geometry. The circle was shown to be the finite mapping of the infinite line, and the donut, or torus, is the finite mapping of the next dimension. A line of points forms a line, shown in blue. A line of these lines forms a plane. Each of these lines has a finite mapping as a circle, shown in red. This line of circles is just another infinite line, so we roll it up into a circle, shown in green. This illustrates dimensional progression and can be expanded to n-dimensional space. A line of these green tori would also get rolled up to form a circle, and so on. Each dimension is a circle composed of an infinite number of its lower dimensional neighbor. This image is the finite mapping of a four-dimensional space, a slice of which produces the finite mapping of the infinite cube. This brings up a potential conflict, discontiguous space. However, take a moment to examine the atom. It is the basic building block of all matter. If we were to magnify a hydrogen atom so that the nucleus was the size of the sun, its single electron would be the size of Jupiter and float in a sphere about the sun at a distance from its current location on out to Pluto. Nothing else would inhabit that massive volume. All solid matter is more accurately defined as a collection of vacuums, since they are composed of less than 1% of 1% of material. We are composed of discontiguous bodies. Using the second dimension as an example, an infinite sheet of paper can represent that universe, the finite mapping of which is the donut shape that we have already discussed. The inhabitants of that paper do not possess the ability to look outside that realm. Therefore, they have no vantage point to determine if their paper universe was crumpled into a ball or torn into millions of pieces. It will always appear to them as infinitely flat and contiguous. This understanding of the lower dimensions must be incorporated into our universe model, and Fluidic Circular Dimensions answers that call. The next episode, Chaos, will examine circular mechanics. Visit the link above for more information and links to all episodes in this series.